Containers use read-only images, and they have various layers. So as you add layers to your image, the new size is only the delta for whatever you've added to that image. When you deploy containers, they're using the same base layers in those images, and that's where the efficiency comes from. They deploy much faster and use less resources, and therefore containers are much more efficient than, say, a virtual machine.
Yeah, so containers work when container execution engines like Docker, or even at a lower level run C, basically wrap a process. So instead of just starting it without any of these isolation primitives, the process is started with all these isolation layers provided around it. So isolating it from other process IDs, isolating it from other file systems. And so basically starting that process with a container execution engine that knows how to set up all those primitives, that's what gives you a container. That's how it operates.
The interesting thing about containers is that they are fundamentally Linux processes. Containers have been around for a long time. They're nothing new. So they're processes that share the underlying kernel. Unlike VMs you actually have, it's a hypervisor that runs on the host, and then it has a full stack. It has its own OS and everything else, all the software. Containers share a kernel, and they run individual processes, Linux processes, on top of that kernel.